Hello students, welcome to Deeksha Online Classes Mathematics Lecture 3 Circles and Functions, and we will discuss some points about relations also, which are very important for JEE Main also. Let us start. Circles. Here I want to discuss how we take the help of algebra to understand the geometrical concept by taking circle as example. If you understand these things carefully, you can use them in parabola, ellipse, hyperbola also. Let us take a standard circle. X square plus y square equals to r square. You know this is the circle with center at origin, radius r. Y equals to mx plus c. This is a straight line with slope m and y-intercept as c. Suppose circle is there in the plane and that line is also there in the plane. So you know that x square plus y square equals to r square means x comma y is the arbitrary point on that circle. Similarly, y equal to mx plus c, x comma y is arbitrary point on the line. Now let us insert one locus into another locus. So here equation is nothing but the condition satisfied by the points in that locus. Now let us substitute y equals to mx plus c in the circle locus. So forget about it is a circle. It is some locus. There are two loci which we are given. So one locus I am inserting into another locus. X square plus y square means what? M square x square plus 2mcx plus c square minus r square equals to 0. So what you will get? 1 plus m square into x square plus 2mcx plus c square minus r square equal to 0. So we got a quadratic in x. See, I moved into now algebra. So what is x? X is the x coordinate of the points in the locus. Is this quadratic in x will be satisfied by the x coordinates of circle or line? It should satisfy both. Why? Because as we inserted line locus into circle locus, we got this condition. So what will happen? If at all this line meets the circle, at how many points it meets, also this equation is telling you. When I got a quadratic, it is telling indirectly that this line and this circle can have maximum 2 points, because when you have two x coordinates which are common for the line and circle, maximum you can have two distinct points common for both. How to get it? You know that if you apply a discriminant value 4m square c square minus 4 times 1 plus m square into c square minus r square, that is 4 times m square c square minus c square plus r square minus m square c square plus m square r square. So m square c square gets cancelled. You will get 4 times r square into 1 plus m square minus c square. So discriminant, why I calculated discriminant? Suppose if that circle and line are like this, you should know that discriminant should be greater than 0. If the circle and line are like this, means tangency, discriminant will be 0. If do not meet, discriminant must be less than 0. Okay, here circle has this special facility that to check these situations, from center of the circle, you can compare the perpendicular distance to the line to the radius of the circle. This is perpendicular distance, this is radius. So by comparing radius and perpendicular distance also you can see the situation. But I want to explain you any curve, any line situations by taking standard circle. So what is the condition for tangency? So delta must be 0. So can I say c square equals to r square into 1 plus m square, which implies c will be plus or minus r root 1 plus m square. So can I say actually y equals to mx plus c, when I took, it is a straight line in the plane. Now it is becoming a tangent to the circle. Then what is happening? In y equal to mx plus c, you have two parameters, m and c. But when that line becomes a tangent to the circle, c is expressed by using radius of the circle and slope. So this equation will have only one parameter, which is called slope. And what does it mean? This is called slope form of the tangent to the circle. So what is its speciality? M is parameter. You can change m values. You can change m values so that you will get all the infinite tangents to the circle x square plus y square equals to r square. So x square plus y square equals to r square will have infinitely many tangents. All those will differ in slope. All those tangents are hidden in this equation. Y equals to mx plus r minus r root 1 plus m square. Now let us take the circle. Now x square plus y square equals to r square is the circle. So when I call y equals to mx plus r minus r root 1 plus m square, all the tangents to this circle are hidden in this. Suppose I am keeping a condition that tangents passing through x1, y1, passing through a given point x1, y1, means these are the infinite tangents. I am applying a condition that, remember, m has infinite values. Then if I put a condition that the tangent is passing through x1, y1, let us use again algebra, substitute x1, y1 in that. Y1 minus mx1 whole square equals to r square into 1 plus m square. So what you will get? Y1 square plus m square x1 square minus 2m x1 y1 minus r square m square, which is here x1 y1 is fixed. So what is parameter? M is the parameter. Before the substitution of x1 y1, m can have infinite values. Now after substituting x1 y1 and after simplifying, I think you are getting x1 square plus r square into m square minus 2x1 y1 into m plus y1 square just wait. I think it is x1 square minus r square into m square minus 2x1 y1 into m plus y1 square minus r square equals to 0. So can we call this as quadratic equation in m? So again, what does it mean? In this equation you have infinite values of m. When you are putting a condition x1 y1, the infinite tangents passing through x1 y1, so immediately the algebra is saying to you that infinite tangents cannot pass through, as m is a quadratic in we got a quadratic in m can have maximum two values. So in those infinitely many tangents, there are maximum two tangents which are passing through x1 y1, so this quadratic equation maximum can have two real and distinct roots. Again the same logic. So let us write that equation again. X1 square minus r square into m square minus 2m x1 y1 plus y1 square minus r square equals to 0. Now its discriminant depends on again delta, whether this m values are real or distinct. So delta equals to what? 4x1 square y1 square minus 4 times x1 square y1 square minus x1 square r square minus y1 square r square plus r power 4. So 4 common. If you simplify, you will get s11. 4x1 square y1 square gets cancelled, and if you take r square common, you will get s11. You know that s11 is nothing but power of the point. Power of the point is nothing but cp square minus r square. If the power of the point is greater than 0, point lies outside. If s11 equal to 0, point lies on the circle. If s11 less than 0, point lies inside the circle. You already know that. Now what we got? I said if the tangents are passing through x1, y1, I got a quadratic in M. That M will have roots real or distinct, or real or equal, or imaginary. That depends on the position of the point. So if the point lies inside, delta should be less than 0. No real values of M, means no real tangent will pass through this point if point lies inside the circle. If the point lies on the circle, this s11 will become 0, so discriminant will become 0. The two real and equal values of M. So two tangents which are coincident, means geometrically only one tangent is possible through that point px1 y1. Suppose if the point px1 y1 lies outside the circle, if px1 y1 lies outside the circle, then s11 is greater than 0. Two real and distinct values for M. Let there are m1 and m2. So according to quadratic equation, m1 plus m2 must be equals to 2x1 y1 by x1 square minus r square, and m1 into m2 will be equals to c by a y1 square minus r square by x1 square minus r square. So the two tangents are like this. So you can find if theta is the angle between them. You can find using m1 m2 tan theta equal to modulus of m1 minus m2 by 1 plus m1 m2 formula, or you have another procedure also. This will be radius and length of tangent will be root s11, and this angle will be theta by 2. Tan theta by 2 equals to r by root s11. Using that also you can find angle between tangents. So we got m1 m2 equal to product of the slopes if point lies outside the circle. There are two possible tangents. Let m1 m2 are those slopes of those two tangents. Then m1 m2 I got y1 square minus r square by x1 square minus r square. Suppose if I say the tangents which are passing through the x1 y1 are perpendicular to each other, assume, then m1 m2 value should be equal to minus 1. Then what you will get? X1 square plus y1 square equal to 2r square you will get. Means if I ask you locus of such points will be x square plus y square equals to 2r square. So what is the specialty of this circle? From this circle, from any point, if you draw two tangents, the angle between those two tangents will be 90 degrees. And this circle is called director circle. This circle is called director circle. Okay, now we can apply and discuss all these things to a circle whose center is x1 y1 and radius r by the concept of shifting of origin. So if origin is shifted to x1 y1 point, this circle x minus x1 whole square plus y minus y1 whole square equal to r square becomes a standard circle. Then I can say that y minus y1 equal to y minus y1 equals to m into x minus x1 plus or minus r root 1 plus m square will be the equation of infinite tangents. Will be the equation of infinite tangents in which m is the parameter, x1 y1 is center of the circle. Don't confuse yourself. X1 y1 is center of the circle. If you want, you can change it to a b. So what you can write here, y minus b equals to x minus a m into x minus a plus or minus r root 1 plus m square. All concepts you can apply. See, you will get director circle for this circle, everything. So this is called slope form of the tangent. It is slope form of the tangent which stores all the infinite tangents present for that circle, where m is the parameter. If you substitute a given point in this equation, it turns into a quadratic in m, saying you that maximum 2 tangents are possible passing through a given point x1 y1. Whether they really exist or not depends on its discriminant, what we discussed earlier. Now, if you, the first discussion what I did, x square plus y square equals to r square and y equals to mx plus c. What I said, there are two circle locus and line locus. One locus I am inserting in this. So if you remember, by putting x square plus mx plus c whole square minus r square equal to 0, you will develop a quadratic in x. Let x1 y1 or x1 x2 are the roots of this quadratic equation. Similarly, now if I write x equal to y minus c by m, let us substitute x in terms of y, then you will get y minus c by m whole square plus y square equals to r square. If you simplify, you will get a quadratic in y. Let y1 comma y2 are the roots. So as you know that whether they really exist or not, it depends on its discriminant. Assume that the situation circle and the line is like this, y equals to mx plus c, and this is x square plus y square equals to r square. Now when I eliminated y and got a quadratic in x, whose roots will be these x coordinates of the common points. When I eliminated x and got a quadratic in y, the roots will be the y coordinates of the common points. Then by using that quadratic, I think you know in quadratic equation difference between the roots, root delta by mod a. By using that formula root delta by mod a, delta is the discriminant of that quadratic equation, a is the coefficient of x square in the first thing, a is the coefficient of y square in the second thing. So suppose if this is AB length also you can find by using x2 minus x1 whole square plus y2 minus y1 whole square. So difference between the roots. Again I am telling you, this is only I am taking the help of standard circle to explain you the concepts. Circle is a special figure which will have its own benefits. So actually we are calculating here length of the chord. We'll discuss again in some other concept what is the facility of circle we use. But here I want to explain you geometry and algebra, how algebra is helpful. So my explanation is general by taking the example of standard circle. Remember, these I can use in parabola, in ellipse, hyperbola also in future. So that's why you observe this or understand this as a general category, general discussions. Now let us discuss general form of a circle. So actually you know that ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0 is a second degree non-homogeneous equation in x and y. Its discriminant is abc plus 2fgh minus af square minus bg square minus ch square. So this is nothing but the determinant of abc f g h. Now if this equation is a circle, this should not be equal to 0 and a should be equal to b and h should be equal to 0. Means xy term should not be there and coefficient of x square and y square must be equal. So by observing these things, we write the general equation of the circle as x square plus y square plus 2gx plus 2fy plus c equal to 0 with center minus g comma minus f and radius as g square plus f square minus c. So this is called general equation of the circle. All the things which we learned for standard circle, that is center, origin, radius r, x square plus y square equals to r square. The only thing is the center is minus g comma minus f. If origin is shifted to this circle will become standard circle. So all the concepts you can shift to general circle by applying that shifting origin concept. Now parametric form of a circle. Parametric form of a circle, the parametric equations are x equals to a plus r cos theta, y equal to b plus r sin theta, where a comma b is center, r is radius. So these are fixed. So what is the parameter? Parameter here is theta. So theta is the parameter. So on the circle x minus a whole square, and the circle x minus a whole square plus y minus b whole square, x minus a whole square plus y minus b whole square equals to r square. Any point this x comma y, that is a plus r cos theta comma b plus r sin theta, we will name it as theta. So from now onwards, if I call a point theta on a circle, try to understand I am talking about parametric point on the circle. So by using this, you know that alpha beta, if you take chord joining alpha beta, tangent at theta, all those things, there are some formulas. Learn those formulas. Whenever we have to use in problems, we'll use them. So that is about parametric form of a circle. Then diametric form of a circle. So what is diametric form of a circle? Suppose you have a circle, you have infinitely many diameters. Of that, one diameter extremities x1 comma y1, x2 comma y2 are given. Then I want its equation, circle equation I want. So let px comma y be a point on the circle. As you know that angle in a semicircle is 90 degrees. The product of slopes of PA and PB must be equal to -1. So if I apply that condition, I'll get x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. So this is the formula to find the equation of circle when extremities of one diameter x1, y1, x2, y2 are given. Now observe carefully. This is a circle. Assume this is the diameter. So A and B are the extremities of diameter. Now using x coordinates, if I ask you what is a quadratic equation, means suppose if I substitute the equation of line in the circle by eliminating y, I got a quadratic in x. Suppose x1, x2 are the roots. So x minus x1 into y minus y1, sorry, x minus x1 into x minus x2. So can we call this x minus x1 into x minus x2 as a quadratic equation in x whose roots are x1 and x2? So similarly, y minus y1 into y minus y2 equal to 0. See, same formula in the previous explanation. What I did, angle in semicircle 90 degrees, I developed a formula, but I am looking it in a different dimension, as if this is a chord or one line equation. If I substitute that line equation in the circle equation by eliminating y, if you get a quadratic in x, you know that quadratic in x roots will be x coordinates of the common points. And if you substitute x in terms of y and eliminate x, you will get a quadratic in y. That quadratic roots will be y coordinates of the common points. Now here the line is diameter. If line is diameter, the quadratic in x, the quadratic in y, the sum, if you equate it to 0, you are getting equation of that circle. So look that concept in this different way also. So looking the same concept in a different dimension is very, very important. Now, okay, now let us discuss circle passing through three non-collinear points. So you know that if 3 points are non-collinear, you can form a triangle. The circumcircle of the triangle is a circle passing through the three non-collinear points. So if you assume that the equation of the circle is x square plus y square plus 2gx plus 2fy plus c equal to 0, as g, f and c are three parameters or three variables, substituting ABC values, you will get three equations in GFC, solve them to get GFC. Some books will write some determinant formulas also. Let us discuss another approach here. That is, before that another approach, let us discuss, suppose there is a circle S equal to 0. Assume this is a circle, x square plus y square plus 2gx plus 2fy plus c equal to 0 is a circle, and as you know that there are some notations. This we call as S, x square plus y square plus 2gx plus 2fy plus c, and you know that S1 is another notation. We write S1 for a point x1 y1 as x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c. Observe, it is a linear degree. Suppose if I write S1 for x2 y2 point, you have to write xx2 plus yy2 plus g into x plus x2 plus f into y plus y2 plus c. It is also a linear degree. S11 for a point we write, it is substituting x1 y1 in the circle, or substituting x1 y1 in S1 also we can say. So x1 square plus y1 square plus 2gx1 plus 2f y1 plus c. S12. S12 means 2 points will be given, x1 y1, x2 y2. So in S1 substituting x2 y2, or in S2 substituting x1 y1, you will get S12, which is also a number which we calculate by taking 2 points as x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c. So please remember S, S1, S2, S11, S12 like this. So S is a second degree equation, S1, S2 are first degree equation, and S11, S12 are numbers. So from the given points we calculate this. So they are called notations. So I am taking let S equals to 0 is the given equation of circle. Now a line is cutting the circle like this. Let it is L equal to 0. Let A and B are the points of intersection of that circle and line. Now I already, in pair of straight lines, if you recollect, I told generating a new locus. In homogenization concept I discussed. At the same time, if ax square plus 2hxy plus by square equal to 0 represents a pair of lines passing through origin, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents another pair of parallel lines to the given pair of parallel lines. Given pair of lines, a pair of parallel lines. That pair is parallel to this pair. Then the other diagonal not passing through origin. There also we discussed how to generate a locus. Now there are two loci we have. One is S equal to 0, one is L equal to 0. Now what I can say, through this AB I want to create new locus. Can I use this like this? S plus lambda L equal to 0. So this is a new locus. Why this is a new locus? Lambda is the parameter I am using. Now let us observe, by using S as this x square plus y square plus 2gx plus 2fy plus c, and L is our line. Let us say that is some Lx plus my plus n. If I substitute the point A in this locus, irrespective value of lambda, it should satisfy, because A lies on S, A lies on L equal to 0 also. A lies on S equal to 0, A lies on L equal to 0. So S will become 0, L will become 0 if I substitute A. So whatever may be the value of lambda, A satisfies this. B also satisfies this. Okay. So the newly created locus, I don't know what it is, but that new locus always passes through AB, I understood. Now if you observe that new locus, it is again a second degree non-homogeneous equation in x and y, and very clearly coefficient of x square and coefficient of y square are equal, and the xy term is not there in this locus. So this new locus which I created must be a circle, but already we understood that it passes through A and B. So as lambda is parameter, this new locus is infinite circles passing through this A and B. Infinite circles passing through A and B. So please remember, if S equal to 0 and L equal to 0, S equal to 0 is a circle, L equal to 0 is a straight line cutting the circle at 2 points A and B. S plus lambda L equal to 0 represents all infinitely many circles passing through A and B for different values of lambda. Now let us use this concept here in our target. Our target is ABC are 3 points. Through those 3 points I have to get the equation of the circle. So what I will do, first I will take any 2 points, let us A, B or B, C or your wish. Take those 2 points, and you know that how to get the equation of circle with AB as diameter. So by using the given 2 points, you can get by using diametric form. First you generate S equal to 0, and using 2-point form, can you get the equation of line also, which is L equal to 0. So from the given 2 points, you are able to develop one circle and one line. That circle as AB as diameter, and the 2-point form line equation. Now this circle and line, I can generate now a family of lines or system of lines which pass through AB. So there will be infinitely many circles passing through A and B, infinitely many circles passing through A and B. In those infinitely many circles, there will be one circle passes through C. Passes through C. So this C point, if I substitute in this, corresponding lambda value we will get out. So resubstitute lambda in that, our required equation which is passing through ABC we can generate. So that is the way how we calculate circle equation. So here my main aim is S plus lambda L equal to 0 as a family of circles. Now next, let us discuss intercepts made by a circle on coordinate axis. So again the same heading is different. The main logic, if you understand my first discussion, geometry with algebra, a lot of things you can solve very easily. Now let us take a general circle, x square plus y square plus 2gx plus 2f5 plus c equal to 0. So this is an equational circle. Let us take first intercept made by circle on coordinate axis. Let us take intercept made by the circle on x-axis. So this is a circle, assume, and let us say this is a x-axis. You know what is its equation? Y equal to 0. So intercept word we can find only if that line meets the circle in two different points. So as you know that this is the part which is intercepted by the circle on the line x-axis. How to get it? Use algebra. Insert this locus into this locus. So y equal to 0, when you are substituting, you will be left over with a quadratic in x. I told you what will be it. So this is the quadratic in x which we got by inserting this locus into this locus. So this locus points on the circle. This locus points on the x-axis. Then by inserting this, whatever we get, it tells you common points. So as it is x-axis, let x1 comma 0, x2 comma 0. So this x1 comma x2 will be the roots of this quadratic. And I told you the length intercepted you can calculate by difference between the roots, root delta by mod A. So here, what is root delta? Under root of 4g square minus 4c, which is 2 root g square minus c, and this a value coefficient of x square is 1. So this is the length of intercept made by the circle on x-axis, 2 root g square minus c. And you know that if this delta becomes 0, means g square equal to c. Suppose if g square equal to c, this length of intercept will become 0. It is nothing but indirectly discriminant 0. What do you mean by discriminant 0? Discriminant 0 means the x-axis meets a circle in two coincident points. That is nothing but tangency. So I can use g square equals to c is the condition for tangency for x-axis. So if a person says that x-axis is a tangent to the circle, g square equal to c is the condition. And what is the length of the x-intercept? Intercept means circle. If it meets x-axis in two distinct points, the intercept made by the circle on x-axis will be 2 root g square minus c. And then similarly, if I take same circle equation, x square plus y square plus 2gx plus 2f5 plus c equal to 0, and let us take y-axis whose equation is x equal to 0. Same logic. Let us insert this into this. You will get now y square plus 2fy plus c equal to 0. So 0 comma y1, 0 comma y2. So this y1, y2 will be the roots of this quadratic equation. Then the difference between the roots will be the length of intercept here. which is nothing but 2 root f square minus c, and this f square minus c, if it is equal to 0, that is delta equal to 0, it is a condition for tangency for y-axis. Okay, now let us discuss intercepts made by a circle on a line. So suppose there is a circle and a line is like this. Already we discussed algebra method, that is inserting the locus of line into the circle, getting quadratic equation in x, quadratic equation in y, getting the difference between the roots. You can find the length of AB. But I told you circle has a speciality. We can simply find intercept made by a circle on this line. Suppose if you draw a perpendicular on the chord AB, let us say CP, it bisects the chord, and this will be the radius of the circle. This is P, which is the perpendicular distance. Then PB will be equal to, by Pythagoras theorem, 1 root of r square minus p square. Then AB will be equals 2 root r square minus p square. So this is the way you can find the length of the chord that are intercept made by a circle on a line. But in general, if it is any curve, we can use the algebra procedure. Now let us discuss equation of circle touching x-axis, y-axis or both axes. Suppose a circle s equal to 0, that is x square plus y square plus 2gx plus 2fy plus c equal to 0, touching x-axis. So you know that g square will be equal to c, then g will be equal to plus r minus root c. Then what will be the radius of the circle? R equals to 1 root of g square plus f square minus c. This g square is equal to c, radius will be mod f. So radius of the circle will be mod f, and center is minus g comma minus f. You can write the equation of the circle. X square plus r minus 2 root cx plus 2fy plus c equal to 0. So this is the equation of circle. The circle can touch x-axis from above or from below according to this plus or minus sign. Okay, now the circle touches y-axis. So x square plus y square plus 2gx plus 2fy plus c equal to 0. So f square will be c if it touches the y-axis. So f equal to plus or minus root c. So the equation of circle becomes x square plus y square plus 2gx plus r minus 2 root cy plus c. So actually circle center can be in any one of the quadrant, but it can touch the y-axis from left or from right. So this plus or minus will decide it. Suppose if the circle touches both axes, so that can happen in any quadrant. So x square plus y square plus 2gx plus 2fy plus c equal to 0, and the condition is g square equal to f square equals root c. Then the circle becomes x square plus y square plus r minus 2 root cx plus r minus 2 root cy plus c equal to 0. So this is the equation of the circle. So if this can happen in any one quadrant. So if you take plus plus, this here plus sign, center will be in third quadrant, so circle will be in third quadrant. So according to plus or minus, in which quadrant the circle is present, we can decide. Next, maximum and minimum distance of a point from the circle. So if you have a circle, let us say C is the center, let a point P is outside the circle. Then what is the minimum distance from P to the circle? What is the maximum distance from P to the circle? To get it from P, join the center and extend. So if you take AB, you know that PA is the minimum distance, PB is the maximum distance. So to get PA, you will do CP minus radius. To get PB, CP plus radius. And when you get the lengths of PA and the AC is the radius, so taking P point and C, and if you use ratio, you can find the point on the circle which is nearer to P, which is far from P. Similarly, if you have point P on the circle, minimum distance will be 0 and maximum distance equals to diameter. If the point lies inside, then just you join the diameter through CP. So minimum will be PA, maximum will be PB. So using radius and CP distances, you can find. So PA into PB equal to S1. Actually, when you are in school, you might have learned in geometry, for a circle, from P, if you draw a secant line, PAB is a secant line and PT is the tangent line. Then you know that PA into PB equal to PT square. Not only that, from P you can draw infinite secants. This will be equal to PC into PD also. But you know that PT, length of tangent, PA into PB equals to PT square, length of tangent is root S11 whole square, which is S11. So PA into PB equal to S11. Now tangent, already we discussed about tangent, but here I want to discuss equation of tangent to a circle S equal to 0 at a point Px1 y1. So when P is on the circle, you want to discuss. When P is outside the circle, you know you have to develop equation of any tangent with slope m and substitute that point, get a quadratic in m. You will get two values of m, so the two tangents you can draw. Suppose if P lies on the circle, actually you can use the same concept. The quadratic in m will have only one root, actually double root you will get, like that also you can find. But geometrically, here you can find equation of tangent at x1 y1 on the circle is notations you can use s1 equal to 0. So for general circle, xx1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. So this is s1. So it's a linear equation. So you will get equation of tangent at x1 y1. See what I am saying, let you know that equation of any tangent to the circle is y equal to, for general circle, that y minus b equal to x minus a plus r minus m root 1 plus m square. You can use that also and substitute this point and get a quadratic in m. Solve it, you will get only one value for m. That m and given point you can use to get the equation. But there is a direct method finding equation of tangent with the formula s1 equals to 0. Then how to get the point of contact of this tangent? Means suppose if I give you equation of tangent, how to get P? So there are two ways you can do. The general way I am telling is, let Px1 y1 be the point of contact So you will write S1 equal to 0 and given line will be there. That line and S1 equal to 0 are represented in the same line. You have to compare the coefficients and get the value of x1, y1. But circle is a special figure. From center of the circle on the tangent, if you use foot of the perpendicular formula, you can get the point of contact on this for the circle. So whatever procedure I am telling, remember it's a general for any figure. Means the general procedures you can use in further parabola, ellipse, hyperbola. Here circle will have a special facility. That facility also we are discussing. Now you know the normal. Normal means what? Suppose px1, y1. This is tangent. The perpendicular to the tangent at P is called normal. So what is the general equation of finding the equation of normal? You can find the equation of tangent at px1, y1. So its slope, take its negative reciprocal, then you will get the slope of normal. Use this point and the negative reciprocal of the slope of tangent. Using that you can find the equation of normal. In general you can do like that, but in circle normal always passes through center of the circle. So from the point of contact and center you can use 2-point form to get the equation of normal. Diameter. So why is a special discussion we are doing on diameter? Actually for any figure, diameter is the locus of midpoints of parallel chords. Suppose for a circle you take some set of parallel chords. Take the midpoints of those chords. The locus of that is called diameter. So that is a definition of diameter. So you can have infinite set of parallel chords like this. The locus of middle points of those parallel chords will give you diameters. In circle, all the diameters are concurrent. Suppose if I say x square plus y square plus 2gx plus 2f5 plus c equal to 0, you know that minus g comma minus f is the center. So all the diameters of a circle are concurrent, and that point of concurrency is nothing but center of the circle. So there is no rule that in every figure the diameter should be concurrent. We will see in parabola the locus of middle points of chords, the diameter, they are not concurrent. Then let us discuss about chord of contact. So what is chord of contact? Suppose if I give you a circle s equal to 0, there is a point px1, y1. From P, which is outside, we can draw two tangents AB. If you join AB, AB is the chord which we got by joining the points of contacts. So this AB is called chord of contact. Chord of contact. So here we get a doubt. Suppose I am giving you s equal to 0. One circle equation I am giving. I will give you a point x1, y1. Can you find for the given circle for the point x1, y1, s1 equal to 0? You can find. You don't know where this point P lies, but you can find s1 equal to 0. Means for the given circle corresponding to this point, a straight line you are developing. So what is this straight line? We don't know, but we are developing the straight line. See, this straight line we will name according to the position of the point. If the circle is given and the point is P on the circle, the S1 equal to 0, we told it's a straight line, it will be a tangent. If it lies outside, the same S1 equal to 0 is this line, chord of contact. Suppose if this point P moves towards the circle, see, observe, the tangent is moving towards left. So as P moves on the circle, that chord of contact moves slowly and it will become tangent. When P comes onto the circle, chord of contact is also becoming the tangent. Then you will get a doubt. Then if the point P lies inside also, because our calculation S1 equal to 0, don't know where the P point lies. That's why if the point P lies also, there should be a line S1 equal to 0. What should be that line? So if you have a circle, if the point lies inside also, if you calculate S1 equal to 0 for this point for the circle, you will get a straight line. You will get a straight line which is outside the circle. That is named as polar. This is very, very important. That is named as polar. So how to understand? But one thing you remember, this polar, if P lies on the circle, it should become tangent. If P lies outside, the same polar should become chord of contact. So polar is defined very carefully. So how the polar is defined? Now let us take circle and a point P. So it can be inside or outside. Okay, for understanding, because outside all those things we already discussed. Chord of contact on, we discussed tangent. Let us discuss P x1 y1 inside. Now how many chords you can draw through P? You can draw infinite chords through P. Now at the extremities of chords you draw tangents. At the extremities of chords you draw tangents. So join this point of intersection of tangents. See what this dotted line I am telling what it is. Locus of the points of intersection of the tangents. Locus of points of intersection of the tangents drawn at the extremities of the chords which are passing through a fixed or given point Px1, y1. So I am repeating. Suppose if Px1, y1 is a point, you can draw infinite chords. At the extremities of chords, you draw tangents. The locus of the point of intersection of the tangents drawn at the extremities of the chords which are passing to the given point P x1, y1 is called polar. Now suppose if P lies on the circle. If P lies on the circle, all the chords through P are like this. Then at the extremities of the chords, draw the tangents. One extremity is common. So all other extremities tangents, if you draw, the locus will be tangent at P. That's why that S1 equal to 0 will become tangent. Polar becomes tangent. So if P lies outside, the polar will become chord of contact. The polar becomes chord of contact. So try to understand. S equal to 0 is a circle for the given point x1, y1. S1 equal to 0 is a straight line. If P lies on the circle, that S1 equal to 0 is a tangent. If P lies outside the circle, that same S1 equal to 0 is chord of contact. If P lies on the circle, the chord of contact becomes tangent. But polar is defined for all three positions. See, tangent we cannot define for a point which is outside or inside. Only on we can define. Chord of contact we can define outside, on also. on is nothing but tangent, but polar can be defined for all these three positions. If it is outside, point P lies outside, polar cuts the circle because it should become card of contact. If point lies on the circle, it should be a tangent to the circle. If point lies inside the circle, polar lies outside the circle. This is about polar. Now, the point P is called pole. The point P is called pole. Now let us discuss some properties for pole. As you already know that if P lies outside, polar is the card of contact. If P lies on, it is card of contact tangent. If P lies inside, polar lies outside. Now I am asking a question. For the center of the circle which lies inside, can we draw polar? We can't, because the cards passing through center will be diameters. At the extremes of diameters, the tangents are parallel, so you can't get the points of intersection of tangents. So for center, polar does not exist. Similarly, in reverse, I can say that, suppose if I say there is a line, what is the pole? So you know that let pole be x1, y1, equation of polar will be s1 equal to 0. Given line and that s1 equal to 0 will compare and we get the pole. Now the question is, for diameter, what is the pole? So as I said, for center, polar does not exist. For diameter lines, pole does not exist. Now, suppose if you take a circle x square plus y square plus 2gx plus 2fy plus c equal to 0, you know that center is minus g comma minus f. Now let us take a point P, x1, y1. Since it is inside, polar lies outside, we took. So what is the equation of polar? I said s1 equal to 0. So x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. Now what is the slope of center and slope of the line joining center and that point P? Can I say this is pole? So slope of the line joining center and pole will be what? Can I say y1 plus f by x1 plus g? Now let us come to the polar equation. So if I take x common here, x1 plus g is the x coefficient, y1 plus f is y coefficient, minus of this will be, this is a slope of polar. Observe these two slopes, the product is minus 1. So what you understood? Can I say like this? Polar is a straight line and is perpendicular to the line joining center and the pole, or that is given point. So polar of a point, if it exists, it is unique. Suppose if I take polar of some collinear points, all those polars will be concurrent. So polars of collinear points are concurrent. In reverse, I can say poles of concurrent lines, poles of concurrent lines will be collinear. So I am repeating, polars of collinear points are concurrent, poles of concurrent lines are collinear, just reverse. So that is about properties of polars and pole. Okay, let us discuss what is conjugate points. Suppose there is a circle S equals to 0. There are 2 points P and Q such that polar of P passes through Q. So the natural polar of Q passes through P. So P and Q are in such a way that The polar of P passes through Q and polar of Q passes through P. Then these 2 points are said to be conjugate points. So let x1, y1, x2, y2 are the 2 points. So what is the polar of the point P with respect to s equal to 0? It should be s1 equal to 0. So which I can say x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. So according to the definition, since the points are conjugate, this point should satisfy this. So if I substitute this, I'll get s12 equal to 0. What is s12? x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c equal to 0. So can we understand that polar of Q passes through P? So that is about conjugate points. So for a given circle s equal to 0, if x1 y1 and x2 y2 are 2 points which are conjugate, then the condition is s12 equal to 0. Next, conjugate lines. Same. Suppose there is a circle s equal to 0. If L1x plus M1y plus N1 equal to 0, L2x plus M2y plus N2 equal to 0 are 2 lines. Let this line has a pole. So every line will have a pole except diameter. Okay. So the line will have a pole if that pole lies on this line. Means there are 2 lines in such a way that pole of one lies on the other. So suppose if I say line 1, line 2, the pole of 1 lies on 2, the pole of 2 lies on 1, then these 2 lines are said to be conjugate lines. So how to create a condition? Very simple. Let us assume pole of first line is x1 y1. Assume. Then you know that for x1 y1 point for the given circle you can write s1 equal to 0 as the polar equation. That equation and equation 1 you compare to get the x1 y1 value. That point if you substitute in the second line, you will get the condition. So that is about conjugate lines. Next, inverse points. So what is inverse point? Suppose there is a circle, center, let P be a point for which this is the polar of P. Then join CP and extend it to cut the polar. You know that this is perpendicular, already proved. Then the line CP where it cuts the polar of P, let it be Q. Then this Q is called inverse point of P. Then naturally, suppose if I draw polar of Q, suppose let us take Q as a point, given point. If you draw polar of Q and join CQ, that CQ meets the polar of Q at P. So this P and Q are called inverse points to each other. So I can define inverse points like this. Simply, if P is the given point, C is the center of the circle, the line CP where it meets the polar of P is called inverse point of P with respect to the circle. So that is inverse point. Let's some points. As in the definition only we understood. If Q is the inverse point of P, then P is the inverse point of Q. Therefore, P and Q are inverse points to each other. And it's very, very clear. If P lies inside, its inverse point lies outside, because polar of P, CP should cut polar of P. So Q should lie outside. So can I say for the point which lies outside, the inverse point should lie inside? So naturally, center inverse point does not exist. Inverse point center does not exist. Every pair of inverse points, listen carefully, every pair of inverse points are conjugate points, but converse is not true. So inverse points are conjugate, but conjugate, every set of conjugate points are not inverse points. Now, suppose if you calculate s equal to 0 is a circle, let P be the point for which you draw the polar, then join CP and extend it to cut Q. Then if you calculate CP into CQ, you will get R square. You can check it. See, everything you can check in the standard circle because it is easy to check. And one more thing, if I ask you find the inverse point of P with respect to the given circle, no need to calculate polar of P and get the CP equation and solve those two equations. Simply if you understand carefully, and the polar of P from center or from the given point, if you use foot of perpendicular also, you will get the inverse point. Okay. Now, according to the definition of inverse point, CPQ must be collinear. CPQ must be collinear. And very important thing is that P and Q points should be on the same side of C only. So you can't have P on one side of center and Q on another side of center. So these are the very important points regarding to inverse points. Now let us discuss chord bisected at a given point. Suppose we have a circle S equal to 0 and there is a chord. Let Px1 y1 be its midpoint. You know that S1 equal to S11 will give you its equation. So when midpoint is given, see, you have several procedure to find this. For any curve, the general procedure I am discussing, you have to use x2, y2, x3, y3 as the extremities of the chord, and you have to substitute these points in the given curve, subtract the curve equation to get the slope, and in that slope you have to introduce x1, y1. How? You know that x2 plus x3 by 2 will be x1, y2 plus y3 by 2 will be y1. So you have to insert x1, y1 into the slope. Then after getting slope in terms of x1, y1, using the point px1, y1 and that same slope in terms of x1, y1, you can get the chord equation. When you want to introduce this curve equation into this, you know that, for example, circle minus g comma minus f is the center, and if you join these two, you can get the slope, and its negative reciprocal will be the slope of the chord. So using the point and the slope of the chord, if you observe carefully, slope of the chord, you have introduced the elements of circle G and F. So you will get this form, S1 equal to S11, and just try to drag the chord so that it becomes tangent. So this midpoint of the chord becomes the point of contact. So S11 becomes 0. Again it becomes the equation of tangent, S1 equal to how much? S1 equals to 0. Now suppose, what is for x equal to 0, S1 equal to S11, if I ask you to write xx1 plus yy1, okay, I will take standard circle xx1 plus yy1 minus r square. This is S1, x1 square plus y1 square minus r square. This is S11. So r square gets cancelled. xx1 plus yy1 minus of x1 square plus y1 square equal to 0. So this will be the chord with midpoint x1, y1. Now locus of midpoint of the parallel chords. So what do you mean by parallel chords? Slopes will be same. What is the slope of this? Minus x1 by y1. With this slope, with this slope, let midpoint is some alpha comma beta. some y minus beta equal to slope into x minus alpha. If you do the simplification, you will get L1 plus lambda L2 form. The point of intersection of L1 L2 will be origin. Just I am telling you here. I already told you locus of midpoints of parallel cards is diameter. All diameters will be concurrent at a point center. That you can check with this concept also. Now let us discuss pair of tangents. Suppose if you have a circle, from a point outside the circle we can draw two tangents, pair of tangents. How to get its equation? So by using a parametric form of the straight line, you have a procedure. Directly you can prove it. S1 square equals to S11 into S. So you know that this is a second degree. Now how much is the equation if you simplify for S equal to 0. But after getting a pair of straight lines from this procedure, you know pair of straight lines concept, you can find angle between the tangents, everything. But same pair of tangents you can calculate in another way which we already discussed. You know that equations of all infinite tangents will be what? Y minus b center is equal to x minus a m into x minus a plus r minus r root 1 plus m square. This will be the equation of infinite tangents of circle. That circle center a comma b, radius r if you use in that previous formula, you will get equation of all the infinite tangents. Substitute x1 y1 point in that. If you substitute x1 y1 point in that, you will get a quadratic in M. Solve it. You will get two values for M. Two values for M. Now use those values of M for this point and use point slope form. You will get two individual tangents equation. You can combine them. If you combine them, whatever you get with S1 square equal to S11 into S, same combined equation you will get. So you can use either of the procedures. Next, direct and transverse common tangents, centers of similitude. Suppose if you have two circles, so in a plane, two circles, you have different positions. We'll discuss. First, let me tell you, if you draw a tangent for both the circles such that the circles lie on the same side of the tangent, then the tangent is called direct common tangent. Suppose if you draw a tangent for which that circles will be on the opposite side, it is called transverse common tangent. Now for this situation, you can draw two direct common tangents and two transverse common tangents. Let C1, C2 be the centers of the circle. Then this point, let us take this as A, this point as B. Very clearly A is what? Point of intersection of transverse common tangent, and B is the point of intersection of transverse common tangents. Centers C1, C2 and AB are collinear. These A and B are called centers of similitude. And A is called internal center of similitude, B is called external center of similitude. A divides C1 C2. See, we can use similar triangles concept to prove A divides C1 C2, line segment C1 C2 in the ratio R1 is to R2 internally. B divides same C1 C2 in the same ratio R1 is to R2 but externally. So I can say that centers of similitude are harmonic conjugates with respect to the line segment C1 C2. Now if I give you two circles, S equal to 0 and S dash equal to 0, you can find their centers, you can find their radii. Then using internal section formula, you can find internal center of similitude. Using the external section formula, external center of similitude. After getting A for any circle, either this circle or this circle, if you observe, the transverse common tangents are nothing but the pair of tangents. So you can use S1 square equals to S11 into S formula to get the equation of pair of transverse common tangents. After getting B, use any circle, because if you observe carefully, for any circle there are pair of tangents. So pair of tangents I discussed in the last concept. You can use them to get the equations of direct common tangents or transverse common tangents. Now I think you know very clearly when you have one circle completely lies inside, what is the condition, how many direct common, how many transverse common tangents. You can once revise them. I think you know length of direct common tangent, length of transverse common tangent also. Let us discuss lengths of direct common tangent and transverse common tangent. If D is the distance between centers, R1, R2 are radii, then length of direct common tangent is under root of D square minus R1 minus R2 whole square. Length of transverse common tangent is under root of D square minus R1 plus R2 whole square. So you can remember them. And now let us discuss common chord of two circles. So this is possible if two circles intersect each other. Let us say the points of intersection are A comma B. So if you join them, it is a common chord. S equal to 0 is one line, S dash, sorry, one circle, and S dash equal to 0 is another circle. Let us say in S equal to 0 and S dash equal to 0, coefficients of x square, y square are all ones only. I am repeatedly saying generating a locus by given locus is very, very important. So what I am doing now, I will do S minus S dash equal to 0. I told you a condition that coefficient of x square and y square, here is 1, here is 1, are same. My logic is same. Why I am putting that restriction? When I do S minus S dash, that x square y square term should get cancelled. So whenever I do S minus S dash with that restriction, I'll get a linear equation. I can say that this always represents a straight line. So that is the first thing I did. And the point A lies on S equal to 0 as well as S dash equal to 0. The point B also lies on S equal to 0 and S dash equal to 0. So A and B, if I substitute S minus S dash, I think A and B will satisfy this equation. So what I proved, S minus S dash equal to 0 is a straight line, always satisfying A and B. So it should be the straight line AB. So can I say equation of that common chord will be S minus S dash equal to 0? So that is how to find common chord. Then common tangent of two circles is same logic. Instead of 2 points, it's only 1 point now. Same, s equal to 0, s dash equal to 0. S minus s dash equal to 0 is the equation of common tangent. Then the question rises, when you have two circles s equal to 0 and s dash equal to 0, through these points a comma b, you can draw infinitely many circles. How to get them? That is nothing but again creating the locus. So how to get them? Suppose lambda 1s plus lambda 2s dash equal to 0. The result will be a second degree equation in which coefficient of x square and coefficient of y square will be equal and coefficient of xy is not there. So this equation which we created will be a circle. And if you observe carefully, a and b satisfies this new equation. Therefore, this should be a family or system of circles passing through a and b. So if lambda 1 equal to 0, you will get s dash circle. If lambda 2 is 0, you will get s equal to 0 circle. So no need to get the circles already there. They are the parents from which you are generating the family of circles. So you can do simply s plus lambda s dash equal to 0 also you can do. Now you can do like this also. S plus lambda times s minus s dash equal to 0. If you recollect this s minus s dash, if I do, I will get AB equation. And observe, I can use any one member and that equation of AB as L equal to 0, you can generate. So this s minus s dash is L. It's just s plus lambda L equal to 0. Can we use in the place of s dash? Yes, you can. So lambda into s minus s dash is equal to 0. So you can generate family or system of circles when they are intersecting. You can develop that family or system in these many ways. Now suppose if the two circles are touching each other, same, everything is same. You can get same lambda 1s plus lambda 2s dash, like that you can generate, or s plus lambda s dash equal to 0 you can generate, different values of lambda, all the circles touching you will get. Now you can do like this also, s minus s dash. So what you will get? Circle, that s minus s dash, let us assume it is L. Then all the circles which touch at that point, all that infinite circles you will get with this family. In place of s you can use s dash also. Now the main question raises, what happens if two circles do not meet each other? Here also, see, the figure don't know the calculations. That is the important thing. Suppose if I do s minus s dash equals to 0, I'll get some line. Now what is that line here? If the circles are intersecting, we named that line as common chord. If the circles are touching, we named that line as common tangent. But if the circles do not meet like this, the generated line L equal to 0 by doing s minus s dash equal to 0, what it is? What it is? Now it will be called radical axis. So what is the definition of radical axis? Radical axis definition is locus of the points whose powers with respect to both circles is equal. Means suppose if I say s equal to x square plus y square plus 2gx plus 2fy plus c equal to 0, and s dash is x square plus y square plus 2g dash x plus 2f dash y plus c dash equal to 0. Powers means what? S11 must be equal to s dash 11. So if you apply x square gets cancelled, and 2 into g minus g dash into x1, let p x1 y1 be the point for which I am calculating powers, plus 2 into f minus f dash into y1 plus c minus c dash equal to 0. If I say locus, you will remove this x1 y1 and replace with xy. Observe carefully, is it not s minus s dash equal to 0 again? See this procedure. I did not kept any figure for this. Means whatever may be the figure, if I calculate the locus of the points whose powers is same with respect to two circles, I am getting a straight line whose equation is s minus s dash equal to 0. So that is called radical axis. Now I can go back and tell that if two circles intersect each other, the radical axis is the common chord. If two circles touch each other, the radical axis is the common tangent. If two circles do not meet, all radical axis will be there. So this will be the radical axis. So we got a very important thing, that if in this case also if I do s plus lambda L equal to 0, for different values of lambda, I'll get different circles. What is the speciality of those circles? This s plus lambda L in this situation also will give you infinitely many circles. If you take any two circles from that, and if you calculate radical axis of those two circles, L equal to 0 will be the radical axis. Okay, let us discuss some properties of radical axis. Radical axis is perpendicular to the line of centers. If AP is the line of centers, radical axis is always perpendicular to the line of centers. If circles are of equal radii, radical axis bisects the line of centers. And if you take any tangent which is common for both the circles, whether it is direct or indirect or transverse, radical axis bisects the common tangents. Now, from any point on the radical axis, if you draw tangents to the circles, the lengths of tangents will be equal, because the definition of radical axis is power is same. Power means what? S11 is same. S11 is same implies root S11 is also same. Means indirectly length of tangent is also same. But why we are using power word? Because suppose if two circles intersect like this, this is radical axis. From this point you can't use the word length of tangent. From this point you can use the word length of tangent. For every point you can use the word power. That's why using power we define. Now suppose if you take any point on radical axis as center, take this point as center, and length of tangent to both the circles, you know that they will be equal. Taking that length of tangent, if you draw a circle, this new circle cuts the two circles orthogonally. Now if n circles are there, the maximum number of radical axis you can generate is NC2. Why? For every two circles you can generate radical axis. And the minimum number of radical axis you can generate is 0. Minimum number you can generate is 0 when the circles are concentric. Because if they are concentric, if you do s minus s dash equals 0, nothing will be left over. Only two constants, subtraction will be 0. So radical axis does not exist if the circles are concentric. So the minimum number of radical axis will be 0 and maximum number is NC2. Now suppose if you have three circles whose centers are non-collinear, so when the centers are non-collinear, you can have three radical axes which will be concurrent, and this point of concurrence is called radical center, and this is a point from where if you draw tangent to any of these three circles, the length of tangent will be same. Taking the radical center as center and length of tangent as radius, you can construct a circle which will be orthogonal to all the three circles. Okay, now let us discuss coaxial system of circles, actually what it is. So the definition of coaxial system of circles is a system of circles or a family of circles. For any two circles, you will have same radical axis. So only one radical axis will be the radical axis of any two circles. Very clearly our previous discussion is telling that only. Suppose if you have two circles intersecting each other, the common chord is the radical axis. And take any one circle S equal to 0 and S plus lambda L equal to 0 will be the system of circles. And you know that for all the family of circles, you take any two circles, all the circles pass through this A and B. So for every two circles, AB will be the common chord, means for every two circles you will have same radical axis. So I can say this is a coaxial system called intersecting coaxial system. So when every member of the system intersects the radical axis in two distinct points AB, that system is called intersecting coaxial system. Suppose if you have a circle and a common tangent, so you know that if two circles touch each other, this will be the common tangent. So if I use again S plus lambda L equal to 0, I will be developing all the infinite circles which touch the radical axis at the same point. So this is called touching coaxial system. If S equal to 0 is there and a line do not meet the circle, then also S plus lambda L, you know, there will be infinite circles. No circle will meet the radical axis. And one important thing here is, suppose if I take this circle and this circle, for these two also L equal to 0 radical axis. Don't think that for two circles radical axis should be in middle. So you can have circles on the same side of radical axis also. But only the thing is, if two circles, one is totally outside other, radical axis will be in middle. But if one circle is inside the radical axis also, still radical axis exists. And this is called non-intersecting coaxial system. Non-intersecting coaxial system. Okay, now simplest form of coaxial system. Simplest form of coaxial system means if you take line of centers on x-axis and radical axis as y-axis. So you'll have x square plus y square plus 2 lambda x plus c equal to 0. So center will be minus lambda comma 0 and radius will be under root of lambda square minus c. This system is called simplest form of coaxial system, and it's very clearly when lambda square minus c should be greater than or equal to 0, minus c should be greater than or equals to 0, then this says that lambda should be minus infinity to minus root c union root c to, you can close it, root c to infinity. So lambda value, what is lambda? Lambda is here, center. With lambda only center is developed. So for this, for the real radius, lambda we have a restriction. Now can I say here, according to c value, suppose c is 0, what will happen? So minus infinity to 0, union 0 to infinity. This lambda can be any real number. Lambda can be any real number. But if c is positive, if c is positive, so minus root c, root c. So if you take this as x-axis, centers of this coaxial system cannot enter in between this. If c is negative, this will become always a positive. For any real value of lambda, center exists. Means every point on x-axis can be center. Now if you observe, in one case, when lambda c greater than 0, these are the last centers. I can say these are the last centers. What is the speciality of these two values of lambda? For this minus root c and root c, they are point circles. Means they are two circles whose radius or radii is 0. And I am saying those are the last centers. So limiting points. So can I define now limiting points as the point circles of the coaxial system? So point circles of the coaxial system. Now some important points we'll discuss. Suppose that simplest form, if you observe, center is minus lambda comma 0 and the limiting points are what? So when radius is under root of lambda square minus c, when this radius lambda square minus c equal to 0, that is lambda equal to plus or minus root c. So can I say minus root c comma 0, root c comma 0 are limiting points. So now if c equal to 0, limiting points are coinciding with origin. If c less than 0, no limiting points. If c is greater than 0, two real and distinct limiting points are there. Now what happens? X square plus y square plus 2 lambda x plus c equal to 0. Suppose if c is 0, what will happen? So every circle passes through origin. Now what is happening? So you know that radical axis is y-axis. So this point of contact is nothing but the limiting point. If c is greater than 0. Now actually the coaxial system is x square plus y square plus 2 lambda x plus c equal to 0. What is the equation of radical axis? X equal to 0. So can I say y square plus c equal to 0 becomes y equal to plus or minus root minus c. If c is greater than 0, radical axis, the circles are not at all meeting the radical axis. Circles are not at all meeting the radical axis. So this is y-axis, radical axis. circles will be like this. The coaxial system will be non-intersecting. Then there will be two limiting points. So when C is greater than 0, two limiting points. So when limiting points are there, that system will become non-intersecting. Suppose if C less than 0, then point of intersections with the radical axis exists, whereas limiting points does not exist. Means circles meets the radical axis in 2 points. Then no limiting points. So please try to understand. For non-intersecting coaxial system, limiting points are 2. For touching coaxial system, limiting points coincide with origin. For intersecting coaxial system, limiting points does not exist. Okay, now some properties we'll discuss. Limiting points will be image to each other with respect to radical axis. So when limiting points exist, you know that when the system is non-intersecting, then the limiting points exist. So one limiting point will be the image of other limiting point with respect to the common radical axis. Now if you take any circle passing through limiting points, will cut every member of the coaxial system, and you can check they will be orthogonal. And limiting points are inverse points with respect to every member. Inverse points, just recollect. The centers of circles passing through both the limiting points always lies on the radical axis. These are the very, very important properties. So I am repeating, the center of the circle passing through both limiting points always lie on the radical axis. So polar of one limiting point with respect to any member of the coaxial system passes through other limiting points, because I said already they are inverse points. Now if I take simplest form of coaxial system, line of centers will be x-axis, radical axis will be y-axis. If I take reverse, line of centers on y-axis, radical axis x-axis, that system which we generate is called orthogonal system or conjugate system. Suppose if you take x square plus y square plus 2 lambda x plus c equal to 0. So what is the center? Minus lambda comma 0. Radius under root of lambda square minus c. Limiting points of this coaxial system will be lambda square minus c equal to 0. So lambda equal to plus or minus c. So limiting points are minus root c comma 0. And a point of intersection of members with radical axis. So for that what we did, we put x equal to 0, then we got x equal to 0, no? So plus or minus root minus c. Now orthogonal system will be x square plus y square plus 2 mu y minus c equal to 0. Orthogonality condition is there, no? 2gg dash plus 2ff dash equals c plus, using c plus c dash. Using that you can develop orthogonal coaxial system. Now its center will be 0 comma minus mu, and its radius will be under root of mu square plus c. Then for the value of mu equal to plus or minus root minus c, means limiting points will be 0 comma plus or minus root minus c. and point of intersections of members with radical axis will be plus or minus root c comma 0. Just observe these things. Lot of informations are there. So according to C is very important role here it is playing. If C is positive, here limiting points exist, point of intersections of members with radical axis does not exist. Immediately what is happening here? Limiting points does not exist, points will exist. And did you observe anything? Here the point of intersection of members with the radical axis will be the limiting points of other system. So what is, if I show you in a figure, suppose if the system is non-intersecting, then you know that L1, L2 will be the limiting points. This is the line of centers, this is the radical axis. Then any member passing to the limiting points will be the orthogonal system. Then if the system is non-intersecting, its orthogonal is intersecting, passing the limiting points of the first system. So if the system, given system is touching, so limiting points will be at origin. Then its orthogonal system also passes through origin and touches at origin. So if the system is touching, its orthogonal is also touching. If the given system is intersecting, then for this system limiting points does not exist. Then these points will be the limiting points of its orthogonal system. That system will become non-intersecting system. Okay, now let us discuss relations. If A and B are two sets, you know that A cross B is called Cartesian product. Let R be a subset of A cross B, then we call R is a relation from A to B. R is a relation from A to B. Suppose if there is a relation from a set to itself, it is called binary relation. A to A is called binary relation. We have several types of relations: one to one, one to many, many to one, many to many, like that. But there are some special types of relations on binary relations from a set to itself. They are reflexive. So R from A to A, reflexive. Symmetric, antisymmetric, transitive. See, this is not there for JEE Advanced, but for JEE Main it is there. Just you, I'm revising just. And any relation R, if it is reflexive, symmetric, and transitive, it is called equivalence relation. If it satisfies reflexive and antisymmetric and transitive, it is called partial order relation. So you have syllabus up to partial order for JEE Main. Please revise. Now functions. You know basic definitions of functions for all the elements of domain. You should have unique image. So f of x equals to y. So it is called a function, and all the set of images is called range, and this A is called domain, B is called codomain. Range is always subset of codomain. No basic algebra of addition and all those things I'm not defining. Directly moving to even functions. I think you know, if f is a function such that f of minus x is equal to f of x. So what is its meaning? Suppose f is a function. You are choosing two elements in f domain of f such that they are additive inverses to each other. Means their sum is 0. If their image is same for all x belongs to the domain of f. So this condition satisfied for every element which are additive inverse to each other. It is called even function. So what does it mean if I put it in the graph? For every x comma y point on the graph, suppose x is positive, if you assume, there will be corresponding symmetric point in second quadrant. That's why if you see cos function, it will be symmetric about y-axis. Odd function, f of minus x equal to minus f of x. What does it mean? F of x plus f of minus x is 0. So what you should understand, suppose minus x comma x, just like even functions, I am choosing two elements in the domain of the function whose sum is 0. Then their images, you know that this is called f of minus x, this is called f of x. These two sum is also 0. Means images are also additive inverse to each other. Images are also additive inverse to each other. Then such functions are called odd functions. So for every point, its opposite quadrant. Suppose if it is in first quadrant, with respect to origin, it will be the image. So the graphs of odd functions are symmetric about origin. Now what is even extension and odd extensions? Suppose there is a function which is defined only on the interval 0 comma a. So when it is defined on this, you cannot talk about even function, odd function on f. But you can create a new function now like this. Suppose if I define a g of x is equal to f of x if x belongs to 0 to a, because already it is defined. Now I'll create a new definition from minus a to 0 as f of minus x, because if x is negative, minus x will become positive. The definition will give you some image. So this g of x is called now even extension of f. Suppose same g of x, if I define f of x in x0 to a, so this is called even extension. Even extension. Now if it is defined minus f of minus x, if x belongs to minus a to 0, this is called odd extension. So if the function is defined in 0 to a, you cannot speak about even and odd functionality of f. So you can extend the domains so that you can create even and odd extensions of the given function. So 1-1 function. You know what is 1-1 function. For distinct elements, you should have distinct images. If f of x1 equal to f of x2, means for x1 and x2, if images are equal, x1 must be equals to x2. x1 must be equals to x2. This is the definition of 1, 1 function. Now, how to check whether the given function is 1, 1 or not? So a function which is not 1, 1 is called many to one function. So you can say that, suppose if the graph of a function is continuously increasing or continuously decreasing, it is even function. Suppose if the graph increases and then decreases, what does it mean? If you draw a line, horizontal line, which is y equal to some k, since y coordinate is k, what does it mean for different x coordinates? Means for different elements in the domain x1, x2, you have same image. That's why it is not 1, 1. So this property you can check with derivatives also. So if you calculate f dash x, it will tell you in the given domain whether it is increasing or decreasing function. If it has only single behavior, it is 1, 1. If it has both behaviors and continuous, it is not 1, 1. Now a function which is not 1, 1 is called many to one. Now how to find number of 1, 1 functions, number of many to one functions? So total number of functions will be always cardinality of codomain to the power of cardinality of domain. Then 1, 1 functions will be cardinality of codomain permutations with cardinality of domain. So many to one functions will be total functions minus 1, 1 functions. So on to functions means very clear. Range will be equals to codomain. Means in the codomain, no element should be left over without pre-image. No element is left over without pre-image. How to check? You have to find the range of the function and compare it with the codomain. A function which is not onto called into function. Suppose n of a is m, n of b is n, the number of onto functions will be n power m minus nc1 into n minus 1 whole power m plus nc2 into n minus 2 whole power m minus so on. And you know that for 1, 1 functions, codomain, cardinality of codomain should be greater than or equal to cardinality of domain for 1, 1 functions. Condition. For onto functions, condition is reverse. And if you want into functions, total functions minus onto functions, you will get. Then a function which is both 1, 1 and onto. The name for 1, 1 is injection, name for onto is surjection. So if it is both injection and surjection, it is called bijection. So the condition is cardinality of codomain and cardinality of domain must be equal. That's why number of bijections will be n factorial. What do you mean by constant function? If all the elements are given image to only one element, it is called constant function. Identity function. F is a function from a to a such that f of x equal to x. It is called function. Inverse function. If f from a to b is bijection, f inverse from b to a, if it is a function, it is inverse and it is also bijection. And if you see the graph of f and f inverse, they will be mirror image with respect to the line y equals to x. And you know that there are some special functions, modulus function, whose graph will be like this. step function, also called greatest integer function. So at 1 it jumps, at 2 again it jumps. This is step function. And the fractional part function, actually any real number you can split into step plus fractional part. So fractional part is nothing but x minus step x. So its graph will be always 0 to open interval 1. Signum function. Signum of x will be mod x by x if x not equals to 0 is 0 if x equal to 0. So this further we can write 1 if x is greater than 0 minus 1 if x is less than 0. So signum graph will be from 1 won't be included, a ray, at minus 1 a ray left side, and the origin. So this is signum function. So these are the functions which are very helpful in understanding later limit, continuity, differentiability of functions. Very easily you can understand with the help of these functions. Composition of functions. I think you know when a and b are two functions, when a and b are two sets, f is a function from a to b, g is a function from b to c, then a direct function from a to c, we call it as g circle f, and g circle f of x is defined as g of f of x. This is called composition of functions. So there are some properties. If f is 1 1, g is 1 1, g circle f will be 1 1. If g circle is f is 1 1, f should be 1 1, g is function enough. Enough I am saying. If f is onto, g is onto, g circle f is onto. If g circle f is onto, g must be onto. So now can I say if f is bijection, g is bijection, then g circle f must be bijection. But if g circle f is bijection, f must be 1 1, g must be onto. Like that you have some important property. G circle f whole inverse equals to f inverse circle G inverse. Next, periodic functions. Suppose if you have a function f, for x you have an image, for x plus t you will have the same image, for x minus t also you will have the same image. So if t is the positive real number for which f of x plus t is equal to f of x for all x belongs to domain of the function, f is called periodic function and this t is called period. So periodic functions properties. So what are the periodic function properties? Suppose if f is a function with period t, a into f of bx plus c plus d is also periodic with the period t by mod b. With the period t by mod b. Suppose if you have f plus or minus g or fg or f by g, where period of f is t1, period of f is g is t2. To find the period of combined functions, you have to use LCM of t1 comma t2. Please remember, when you do LCM, you will get period, but it may not be fundamental period. Further, you have to check the submultiples of period to get the fundamental periods. Now how to draw the graph of y minus b equals to f of x minus a when y equals to f of x. So if you observe y equals to f of x, it's just like shifting origin to a comma b. So when you shift origin to a comma b, it becomes this y minus b equal to f of x minus a becomes y equal to f of x. So when y minus b equal to f of x minus a is there, you have to shift the graph a units positive direction y x-axis and positive b units positive direction of y-axis. For example, if you have y equal to mod x, y equal to mod x minus 1. So what will happen? This is mod x, then x minus 1, no, 1 unit. Where you have to move? Positive direction of x-axis. So if it is y equals to mod of x plus 1, negative direction you have to. So similarly, if it is y minus 1 equal to mod x, on positive direction of y-axis it moves. If it is y plus 1, in the downward direction it should move. Now suppose if you know the graph of y equal to f of x, how to draw the graph of y equals to f of mod x? So you know that f of mod x will be f of x, if x is greater than or equal to 0, will be f of minus x if x is less than 0. So what we have to do? Graph of f of mod x and f of x would be identical in the first and fourth quadrants, because where x is greater than or equal to 0. And the graph of f mod x would be symmetrical about y-axis, as mod x is even function. So how to draw the graph of y equals to mod f of x from the graph of y equals to f of x? Here what you are doing, image you have to make it positive, means always images are positive. Means simple example I will tell you. Actually f of x equal to mod x from f of x equal to x I will tell. Very simple to understand. This is y equal to x, but I want mod x. This is already positive, so no effect. This will be taken as image. So this will be the mod x graph. Okay, I discussed some transformations of the graphs of function. Thank you.